Hello, my dear friends. How are you all? So you are very welcome in our lecture number third of real number. So I hope you will enjoy this lecture. Today again we will discuss a very important and interesting topic. Okay. So now without wasting the time, let's start. Yes. So today we will discuss the fundamental theorem of arithmetic. Okay. What is? Yes, the fundamental theorem of arithmetic. So friends, before starting the theorem of arithmetic, we have to know what is prime factorization. What is prime factorization? Okay. So friends, prime factorization is the method of expressing a natural number. It is a method of expressing a natural number as a product of prime number. Okay. Let's take an example. If we talk about 6, okay, 6 is a natural number. Okay. Now, if we break in the product of prime factors, how we can break? Yes, we have two factors. Yes. So the least number is 2. 2 3 is a 6. And the least number is 3. Yes. So the factors of 6 are 2 into 3. Okay. So, friend, these are the factors which is the product of prime numbers. Okay. Which is the product of prime number. 2 and 3 are also prime number. Okay. What? Yes. Prime number. Okay. So I hope you got this point. What is prime number? Let's suppose if we take the example of 36. Okay. So now we have to break 36 in the product of prime number. Yeah, we can do very easily. Yes. 36 is divided by the least number is 2. Yeah, we can divide by 2 by 18 times. Okay. Now again 2 by 9 times. Now 9 can be divided by 2? No. So it can be divided by 3. How many times? 3 times. Okay. Now again 3 ones are 3. So our result is 2 into 2 into 3 into 3. Okay. So again 2 and 3 are the prime numbers and it is break in the product of prime number. So what is prime factorization? Prime factorization is the method of expressing a natural number as a product of a prime numbers. Okay, I hope you got this point. What is prime factorization? Okay, so now, yes, now again we have to do a question regarding the prime factorization. Yes, determine the prime factorization of the number 1395. 1395. Now we will do this question by prime factorization tree. Okay, by tree method. Okay, by branches method also we can say that. Okay, so how we can do? Yeah, so first of all, 1395, we have a number. Okay, yeah. Now firstly, when it is divided by 2, now no, we cannot divide it by 2. 3, no. 4, no. Yes, we can do it by 5. We can do it by 5. How many times? Here is 5. How many times? 2, 7, 8, 3. Okay, if we divide 1395 by 2, it will break in one. Just a minute, wait a second. Yeah. Okay. So now let's do the yes, yes, yes. 1395. If we divide by 5, 5 to the 10. Okay, what is the result? 3, again 9, now it will goes to, yeah, 7 times 35. Here comes, now the result is, what is the result? Yes, 4. Now 5. So what is the result? 5 9 is 45, and the remainder is 0. Okay, so what is the result? 279. Yeah, yeah. Yes. Now, what is the number which can we divide 279? So we will see. Yeah. Can we divide it by 2? Of course not. Yeah, we can divide it by 3. So we can divide it by 3. How many times? 3 nines are 27 and 3 threes are, yes. Okay. Now again, 93 again divide by 3. How many times? 3 threes are 9. 3 ones are 3. Now 31. Now 31 is the number which cannot be divided by any of the numbers. So this is the prime number. Now, so 1395 can be expressed in the product of prime numbers of 5 into 3 into 3 into 31. Okay, 5 into 3 into 3 into 31. So I hope you got this point. So now we will move on. Yes. So this is a main topic, fundamental theorem of arithmetic. So we are discussing about the theorem. What is theorem? Says that, so the theorem states that every composite number can be expressed, can be, yes, can be expressed or factorized as the product of primes. Okay, and this factorization is unique. This factorization is unique apart from the order in which the prime factors occurs. Okay, so this is the important line. Apart from the order in which, means order doesn't matter. Okay, let's suppose take an example of 36. Okay, now if we are breaking it in the product of prime numbers, 2 into 2 into 3 into 3. Okay, got it? Yes. Now, so the first statement that says that every composite number, yeah, 36 is the composite number, can be expressed as the product of primes. Yes, this is the expression of product of primes. And this factorization is unique. Yes, of course, this factorization is unique. Okay, because let's see, 2 into 2 into 3 into 3. Okay, so these numbers, okay, this expression is not come in any of the numbers, any of the factors, any of the composite numbers. Okay, so any composite number cannot be expressed like 36. Okay, so that's why this is a unique. Okay, now apart from the order in which the prime factors occur, what is saying that it's saying that we can write it as 2 into 3 into 2 into 3, or 3 into 2 into 3 into 2, or 3 into 3 into 3 into, sorry, 2 into 2 into 2. Okay, so the result is always same. 36, 36, 36 means the order doesn't matter because it is a commutative properties. Multiplication is a commutative properties. Okay, so I hope you got this point. So every composite number can be expressed as the product of primes, and this factorization is always unique apart from the order in which the prime factors occurs. Okay, so I hope you got this point. Yeah, so let's now move on. Yes, now we are talking about method of finding LCM. Yes, yeah. Now we are learning about how to find LCM. So this is very important topic. Okay, so now, so first of all, we have to know what is LCM. Okay, what is LCM? So now, so the basic formula of LCM is that we are talking about the full form of LCM is that, okay, least common multiple. What is the formula of LCM? Least common multiple. Okay, I hope you got this point. So now, friend, we will start finding the LCM directly with the help of example. Let's suppose, for example, we have to find the LCM of 36 and 56. So, friend, before starting the LCM, before starting to find the LCM, we have to find the factors of each of the numbers. We have to find the factors of each of the numbers. Like, first of all, we have to find the factors of 36. Okay, so what is the factors of 36? We already know about that. 2 into 2 into 3 into 3. Okay, now what is the factors of 56? The factors of 56 is 2 into 2 into 2 into 7. Got it? Yes. Now the uncommon prime factors are those which are not common. Simple. So the uncommon prime factors are 3, 3, okay, 2 and 7. And the common prime factors are 2 and again 2. Okay, so the LCM is equals to, first of all, we have to write the common parts. Okay, so there are two commons, 2 times 2. Okay, so we just write 1 times. So yes, 2 into. Okay, now from these two 2's, we just write only 1 2. Okay, again, from these two 2's, we just write only 1 2 and write the rest of the uncommon parts. What are the uncommon parts? 3 into 3 into 2 into 7. Okay, so I hope you get this point. So what is the result? If we multiply this expression, the result would be 504. Okay, so the LCM of 36 and 56 is equals to 504, which equals to 504. Okay. Yes, exactly. So I hope you get this point. How to find the LCM. So this is the basic method. This is a very easy method finding the LCM. Okay. Yeah. Now let's move on. Now we are learning about the method of finding HCF. So first of all, before starting, we have to know what is the formula of HCF. So the formula of HCF is that, yes, highest common factors. Okay, formula of HCF is highest common factors. So in previous lectures, we already know how to find the HCF using algorithm method, using, yes, Euclid's algorithm. Okay, so now here we are finding HCF by prime factorization method, Okay, so in this method we have a two numbers. Okay, so we have to express both of the numbers in the product of their respective prime factors. Okay, so now then we select the prime factors that are common into the both the numbers. Okay, let's suppose, for example, now we are taking the examples directly. The examples are, first of all, we have to find the HCF of 20 and 24. Okay, so now, yes, first of all, we have to write the factors of 20. What are the factors of 20? 2 into 2 into 5. You can find the factors of 20 by prime factorization method. Okay, now again, what is the factors of 24? The factors of 24 are 2 into 2 into 2 into 3. Okay, great. Now for finding the HCF, we have to just take the common parts in both the factors. What are the common parts? Let's see. So the common parts are, first, these two. Okay, and the second, these two. Yes, and we will write here 2 into 2, and the result is 4. So the HCF of 20 and 24 is always 4. So this is a unique. Okay, so I hope you get this point, how to find HCF. HCF means highest common factors. Okay, yes. So now let's move on. Now important formulas. Okay, so now we will see what are the important formulas. So the first formula is that if we have two numbers, okay, A and B, okay, these two numbers are positive integers. These two numbers are positive integers. Now the formula says that A multiply B is equal to HCF of A comma B multiply LCM of A comma B. Okay, Yeah, so the product of two numbers is always equal to product of two numbers is always equal to product of HCF into LCM of their numbers. Okay, so I hope you get this point. What is the formula? Is that formula says that the product of any two of the numbers is always equals to product of HCF and LCM of that number. Okay, so I hope you get this point. Now again there is a another formula, second number. If we have three numbers A, B and C, these are also positive integers. Okay, so now LCM of A, B, C is equals to product of A, B, C into HCF of A, B, C. Okay, divided by HCF of A comma B dot HCF of B comma C dot HCF of C comma A. Okay, listen guys, this is not a very dangerous formula. It's just look like a dangerous, but it is very easy formula. If you want to know the LCM of A, B, C, you have to just put the A dot B dot C dot HCF of A, B, C divided by HCF of AB dot HCF of BC dot HCF of CA. That's it. Okay. So if you want to find the HCF in spite of LCM, so just it is very easy. A dot B dot C dot LCM of A comma B comma C divided by LCM of A comma B comma C. Okay, here is B dot, sorry, here is just A dot A comma B. Okay, A comma B dot LCM of B comma C dot LCM of C comma A. Okay, so I hope you get this point. So there are two formulas. If we have a two numbers A and B, positive integers, now the product of two numbers is always equals to product of their HCF and LCM. Okay, so now if and the second formula is that if you have a three numbers A, B and C, these three numbers are positive integers, and we want to know the LCM of three numbers A, B, C. So the direct formula is that the product of A dot B dot C dot HCF of A comma B comma C. Okay, it will be divided by HCF of A comma B into HCF of B comma C into HCF of C comma A. Okay, and if you want to find the HCF of these three numbers A comma B comma C, we just directly find by the formula. What is the formula? The formula is that A dot B dot C dot LCM of ABC divided by LCM of A comma B dot LCM of B comma C dot LCM of C comma A. So guys, I hope you get these three formulas. Okay, very easy formula. So now application of HCF and LCM in the real world. So by HCF and LCM, we can split things into smaller sections. Okay, so with the help of HCF and LCM, we can split the larger things into a smaller section. Okay, and to equally distribute any number of set of items into their largest grouping. Very easy. Okay, to figure out how many pupils we can invite. Okay, this is very important topic. Okay, this is very important applications. Okay, and the next application is that to arrange something into rows or columns. To arrange something into rows or columns. Okay, I hope you understand these things. What is the applications of HCF and LCM? Okay, so now let's move on. Yes, properties of HCF and LCM. Now, what is the properties? So the first properties is that, yes, first properties is that the HCF of a given number is not greater than any of the number. Let's suppose we have a two number, 20 and 24. Okay, so what is the HCF? HCF is 4, which is greater than both of the number. So the first property says that the HCF of a given number is not greater than any of the two numbers. Okay, yes. And now second property says that the LCM of given number is not less than any of the given number, is not less than any of the given number. Let's suppose LCM of 36 and 56. Here is HCF, here is LCM. LCM of 36 and 56 is what? The LCM is 504. Okay, so this number is not less than from these of the numbers. Okay, so I hope you get this point. So now our third properties is that the HCF of given numbers is always factors of their LCM. Okay, so HCF of a given numbers is always the factors of their LCM. It is obviously okay. Let's suppose again 20 and 24 HCF. Okay, now it is a 4. If we find the LCM, okay, if we find the LCM, so what is the LCM? So 20's factors are 2 into 2 into 5, and 24 factors are 2 into 2 into 2 into 3. Okay, so now 4. So the property states that the HCF of a given number is always factors of their LCM. Okay, factors of their LCM. So the factors are these and these. So 2 into 2 and the remaining part are 5 into 2 into 3. So the factors of LCM are this, and 4 is this is included in the factors of LCM. So I hope you get this point. Now our fourth property, the HCF of two co-prime numbers is 1. Always, if we have a two co-prime number, what are the co-prime numbers? Those numbers in which there is no common, no factors except 1. Okay, so if we take 4 and 5, so HCF of 4 and 5 is always 1. Okay, and the next properties is that the LCM of two or more co-prime numbers is equal to their product, the HCF of two or more co-prime number. Okay, is equal to their product of their numbers. Let's suppose if we want to find the LCM of 4 and 5, these numbers are co-prime number. So the LCM is that 4 into 5 means 20. I hope you get this point. So these are the properties of HCF and LCM. Okay. So now let's move on. Yes. Now we are doing examples. Okay. Yes. So the first question is that express each of the following as a product of its prime factors. So now we have to convert it into the product of prime factors. Okay. Yes. So the first question is that we have to find the prime factors of 140. So let's do it. This is very easy. So what are the factors? If we do by this method, prime factorization method, we can easily divide. So 70 times to 35 times. Okay. 5 times 7, 7 1 times. Okay. So the factors are 2 into 5 into 7. Okay. 1 is the common factors in all the numbers. Okay. Yes. So now similarly we can find the factors of 156 very easy. How? So the factors of 156 are 2 into okay, 13 into 3 into 1. Okay, we can write also 2 square into 13 into 3 into 1. Answer. Both are correct. Okay. Now let's move on. Yes. The factors of 3825. What are the factors of 3825? We can find very easily. So now the first least number is 3. We can divide it by 3. Okay. Now the another number is 3. Okay. Now next is 5 into 5 into 17 into 1. Let's do that. Okay. 3, 8, 2, 5. It can be divided by 3. 3 ones are 3. 3 2s are 6. 2 and 2. Okay. 3 7s are 21 and 3 5s are 15. Again, it can be divided by 3. 3 4s are 12. 3 2s are 6. 3 5s are 15. Now can it be divided by 3? No, it can be divided by just only 5. So 5 is the 40 and the remaining is 2 and 5 25. 5 5 is 25. Again, it can be divided by 25. Oh, sorry, 5. How many times? 17 times. And 17 is the prime number, so it can be divided by itself, means 17 by 1 time. So this is our result. Now we can easily divide. We can easily find the factors of 7, 4, 2, 9. So what are the factors? 17 into 19 into, you can do it by yourself. Okay. You have to do it. 13 into 1. Okay. So I hope you got this point. So now let's move on. Now find the LCM and HCF of the following pairs of integers and verify that LCM and into HCF is equals to product of the two numbers. Okay. Yes. So now, so for finding the LCM and HCF of their number, firstly we have to find the factors of these numbers. So what is the factors of 26? So the factors of 26 are 2 into 13 into 1 and factors of 91. So factors of 91 are 7 into 13 into 1. So for LCM, we just write here the common part. The common part is 13 and the rest of the uncommon parts means 2 into 7. So the result are 182. Okay. So now we are finding HCF. So HCF is just right here, the only the common part means 13. So HCF is 13. Now we have to verify LCM into HCF is equals to product of the numbers. So now let's do that. So what is the LCM? 182. What is the HCF? 13. And what are the numbers? 26 into 91. If you multiply these numbers, so the result is 2366 is equals to 2366. Hence proof. Okay. Yes. Let's move on. Yes. 510 and 92. So again, firstly we have to find the factors of 510. So what are the factors? So 2 into 3 into 13 into 5. And factors of 92 are 2 into 23. Okay. So now what is the LCM? So LCM is that the common parts are these two. Okay. So here is 2 into and rest of the uncommon parts. This 2 into 3 into 17 into 23 into 5. And the result is that. What is the result? So the result is that 2, 3, 4, 6, 0 means 23,460. Now what is the LCM? Oh, sorry, HCF. So the HCF is only 2. Okay. Now we have to verify 510 into 92 is equals to product of LCM and HCF means 23460 into 2. So if we multiply 510 into 92, it is always equals to 46920. Here this is also equals to 46920. Hence proof. Okay. So I hope you get this point. So now let's move on. Yes. Now finding the HCF and LCM of the following integers by applying the prime factorization method. Okay. So now let's start. So again, for finding the HCF and LCM, first of all, we have to do what? Yeah, we have to find the factors. So the factors of 12 are 2 into 3. Okay, and factors of 15 is 3 into 5. Factors of 21 is that 3 into 7. Okay, now what is the LCM? LCM is, what is the common parts? The common part is that 3, 3 and 3. So here we write the common parts. Yes, 3. And write the rest of the uncommon part, means 2 into 5 into 7. And the result is that 420. Now HCF. So the HCF is that just only the common part, means 3. Okay, this is our result. Okay, now let's move on. Yeah, 17, 23 and 29. So now, what is the factors of 17? So the factors of 17 are, because 17 is a prime number, so 17 and 1. Again, factors of 23 is 23 and 1. Factors of 29, 29 and 1. Okay, so the result is, so the LCM is, yes, common part is 1. 1 is always the common parts of the all numbers. Okay, yes, so into 17 into 23 into 29. Okay, and HCF is that, HCF is just only 1. Okay, because 1 is the only the common in all the 3 numbers. Okay, now if you multiply this, what is the result? So the result is 11339. If you multiply these numbers, you get this result. Okay, so I hope you get this point. Yes, now we have to find the HCF and LCM of 144, 182 and 192. This is very important and very easy question. Okay, so now first of all we have to find the what? We have to find the factors of 144. So what are the factors? 2 into 2 into 2 into 2 into 3 into 3. Okay, so this is the factors. And the factors of 180 are, what are the factors? 2 into 2 into and 3 into 3 into 5. And the factors of 192 are 2 into 2 into 2 into 2 into 2 into 2 and multiply by 3. So now first of all we have to find HCF. What is HCF of the given number? So the common numbers are these two, and this, and these two, this and this. Okay, so the HCF is, and 3 is also the common in all the numbers. This 3, this 3 and this, only 1 3. So the result is that 2 into 2 into 3. We write here just only the common numbers. So now LCM is, now first of all we have to write the common part. So the common part is 2 into 2 into 3. Okay, my dear friends, I hope you get this point. Now in this case, this 2 and this 2 is common, so we have to write 1 this 2, and this 2 and this 2 is common, so now we have to write this 2. Okay, so now my dear friends, and write rest of the uncommon part. So what is, yeah, so the rest part is this and this, so 2 into 2. Now comes on the 3. So now my dear friends, in this case we have this 3 and this 3 common, so we have to take, yes, we have to take just 1 3. Okay, my dear friends, I hope you get this point. So now rest of the common part is 5, so we have to write 5 one time. So my dear friends, this will become 2 raised to power 6, 1 2 3 4 5 6. Okay, and 3 raised to power 2, 1 and 2. Okay, and 5 raised to power 1. Okay, so this is the LCM, which is equals to 2880. Okay, my dear friends, I hope you get this point. So now let's move on. Our next question is that, given that HCF of 306 and 657 is 9, and find the LCM of 306 and 657. Okay, so now first of all, what we can do is that we have two numbers, 306 and 657, and our formula is that A multiply B is equals to LCM of their product multiply by HCF of their product. Okay, so we have A and B. A is 306 and B is 657. It means 306 multiplied by 657. We know HCF, but we don't know LCM. So LCM as it is, and HCF is 9. So the LCM is equals to 306 multiplied by 657 divided by 9. Okay, so the final result is that, what is the final result? Yes, the final result is that 2 2 3 3 8. So LCM of 306 and 657 is equals to 22,338. Okay, yes, so this is our answer. So now let's move on. Yes, now our next question is that, explain why 7 into 11 into 13 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay, so now first of all, taking 13 as common factors from both the numbers, taking 13 because 13 is come in both the parts, this 13 and this 13. Okay, now we get from here 7 into 11 into 13 plus 13, so we get 13 into 7 into 11 is 77. Okay, plus 1, so we get 13 into 78. This is 3. So we get what is? Yes. So we can write here also the factors of 78. What? So 13 into. The factors of 78 are 2 into 3 into 13. Hence 7, 11 and 13 in multiplication plus 13 is a composite number. So we can write this also. So this number is composite number. I hope you get this point. Now let's take the other number. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Let's again take 5 as a common, and the result is 7 into 6 into 5 into 5 is gone in the common, so here is 5 is not come. Here we can write 4 and into 3 into 2 into 1 plus 1. Okay, now 5 into, if we multiply this number, if we multiply this number, we get what? We get 1008 plus 1. Okay, and we can write it as also 1009. So by this we can say that this number is also composite number. Okay, so friend, now I hope you get this point. We we have done a lot of questions in our lecture. So now today we are finishing here, and now we will meet in our next lecture. So friends, thank you very much for listening me.